Welcome to Tech Inquiry, where you and I explore the world of advanced technology. Today, we're going to explore the three principles of quantum computing: superposition, qubits, and entanglement. All right, let's dive in and start understanding quantum computing. You're not going to be running a research laboratory out of IBM after this video, but you will understand it a lot better. All right, first, let's talk about the hardest one to understand: superposition. Superposition shows us that a quantum particle can be in multiple states or places at the same time. Early physicists used a comparison that by today's standards is pretty brutal, but it worked to explain it back in the day. Have you heard of Schrodinger's cat? The theory goes that if you put a cat in a box and seal it up with a decaying isotope that will eventually poison the cat will both be dead and alive at the same time until measured by an outside observer. Don't worry, no cats were harmed during the creation of this theory. But it was an easy way for them to explain superposition to people that didn't understand physics. When you measure superposition, you measure the spin of the quantum particle. Now, until measured, this spin could be in any direction within a 360-degree circle. So now we know the basics of quantum superposition, so what does that have to do with quantum computers? In quantum computing, we take advantage of superposition to create what are called qubits, or quantum bits. They work very similar to the bits you have in your phone or your computer, but thanks to superposition, instead of one bit being either on or off, it can be both at the same time. This is a massive advantage for quantum computers because they can drastically speed up calculations. Now, you might be wondering, how does superposition and qubits help us solve complex problems? Well, let's imagine a gigantic maze that spanned the entire world, and you had to get through that maze and find the exit. A classical computer would have to check every path one by one. Even with some supercomputers having 1 million cores so they could check 1 million paths at the same time, if you have trillions of paths, it's still not going to matter. It's still going to be very slow. And some scientific processes have dozens of problems, all with trillions of paths of their own. That's why quantum computers come in so handy, because they can explore all the paths simultaneously. Alright, we're about to wrap up and get to the last lesson of quantum computing. But first, can you please do me a favor and help me share this message? I want to get this information out to more people because I want to inspire teens and young adults to get more into tech and science. The more people know about technology and science, and the more brainstorming that goes on, the farther we can get in our technological development. And lastly, if you personally have enjoyed this content, please consider subscribing. I'll be releasing videos every week about technology that you may find interesting. Alright, let's wrap this up with entanglement. Entanglement is like having a magical connection between two particles. You do something to one and it affects the other instantaneously. And the coolest part is, it does not matter how far apart they are. Entanglement allows quantum computers to perform calculations in parallel, exponentially increasing their processing power. Just imagine the possibilities: complex problems solved in minutes, or instantaneous communication. Those are the basics of quantum computing, but a lot of people ask me what I think the future of quantum computing is. So let me tell you that if you're interested. Qubits are extremely sensitive to outside disturbances, so scientists are working really hard on how to stabilize them, because even the tiniest interference can cause instability and loss of data. But every day, giant companies like Google, IBM, and now Intel are working on quantum computing. So I think within the next 20 to 30 years, we'll have stable quantum computing chips. The biggest question I get all the time is, will you have a quantum computer someday? And of course, with the current way quantum computers are built and the expense, no one can really own them in their home. But that doesn't mean that new discoveries and advancements in the technology won't lead to miniaturization, just like the miniaturization of traditional computers. No one could afford a traditional computer that barely did anything that was the size of a house. And that's the relative level of advancement we're at with quantum computers. It's basically like traditional computers, but in the 50s. But I think over time, just like with traditional computers, we'll miniaturize them, make them more affordable, and find applications for them. So yes, you might have a quantum computer in your pocket someday. And I'll see you in the next one.